Russia has deployed its latest nuclear-capable missiles to Belarus. The newly developed Russian hypersonic nuclear-capable missile known as the Oreshnik.
Russia isn't just building weapons. It is rebuilding aircraft, shrinking reactors, wiring AI into machines, and pushing new systems into the sky, the sea, and the battlefield. But the deeper you look, the stranger it gets. Because these 10 technologies are not just separate inventions. Together, they hint at something much bigger. A country trying to reshape power transport and war all at once. Number 1. MC-21 Airliner with Russian systems. The MC-21 is more than just a passenger plane. It is also a test of whether Russia can build a modern airliner using mostly its own parts, materials, and systems. In June 2025, Rostec said the MC-21 prototype with Russian systems had entered certification testing. During one test flight, its radio equipment was checked over 4 hours at different altitudes. This project is not only about engines and electronics. Rostec also said the Russian-made cockpit glass passed strength tests, including a bird strike test at over 600 kilometers per hour. Step by step, Russia is trying to turn the MC-21 into a plane that depends much less on foreign suppliers. Why does this matter? Because a modern passenger jet is not just a vehicle. It reflects a country's strength in manufacturing, engineering, materials, and long-term planning. If the MC-21 succeeds, it will show that Russia is trying to rebuild its civilian aviation industry from the ground up. Number 2. SJ-100 Import Substituted Passenger Jet. The SJ-100 is a smaller passenger jet, but it carries a big responsibility. It is the import-substituted version of Russia's Superjet, created to replace many foreign parts with Russian-made systems. Its goal is to keep regional air travel running, using more local technology. In November 2025, Rostec said the first import-substituted SJ-100, built with commercial technologies, completed its first flight in Komsomolsk-on-Amur. The company said the aircraft used Russian systems and equipment, including PD-8 engines, and was built at a mass production factory instead of as a one-time test model. Rostec also said that 24 commercial aircraft were already in different stages of production, while certification work continued. Why does this matter? Because this is not just an engineering project. It is also about keeping domestic air travel working under supply pressure. If the MC-21 is about rebuilding a major passenger aircraft program, then the SJ-100 is about making sure everyday regional flights can continue on a large scale. Number 3. RITM Small Modular Nuclear Reactors. Russia is also working on smaller nuclear reactors instead of only building huge nuclear plants. These compact reactors are designed to provide power and heat in remote places where normal energy systems are weak, expensive, or difficult to build. This is where Rosatom's RITM series becomes important. Rosatom says these small nuclear plants can supply electricity and heat to remote areas, industrial sites, and isolated regions where fuel delivery is hard and long power lines are unreliable. One major example is the RITM 200N based project in Yakutia. Russia also showed international ambition when it signed an agreement with Uzbekistan for a small nuclear power plant using Russian technology. These reactors are meant to be more flexible and easier to use in difficult geography. Why does this matter? Because energy is not only about producing electricity, it is also about delivering it where people actually need it. Smaller reactors could help remote regions grow without waiting for giant grid systems or massive power stations. Number 4. Academic Lomonosov Floating Nuclear Power Plant. Russia has also taken nuclear power in a very unusual direction by putting it on the water. The Academic Lomonosov is a floating nuclear power plant, which Rosatom describes as the world's only operational one. Instead of being built on land like a normal plant, it works from a large floating platform. The plant has 2 KLT-40S reactor units and is designed to provide both electricity and heat to remote regions. Rosatom says it operates in Pivek and helps meet the energy needs of the Chukotka region, where harsh weather, long distances, and weak infrastructure make traditional power projects much harder. Rather than building a huge plant far away, this system brings the power source closer to where it is needed. Why does this matter? Because it makes nuclear energy more flexible. It shows that power plants do not always have to stay fixed in one place. In difficult regions, a floating plant can become a practical way to deliver energy where normal construction would be far more challenging. Number 5. Russia's quantum computers. Russia is also trying to enter the world of quantum computing. This is very different from planes or reactors. Here, the goal is to control tiny quantum states, so computers can solve certain problems that normal machines find extremely difficult. Russian researchers have reported a 50-qubit quantum computer based on neutral atoms, and later a 72-qubit system was also reported. These are still research machines, not products for everyday use, and they are part of a longer development process. But they show that Russia is seriously trying to compete in one of the hardest areas of modern science. Why does this matter? Because quantum computing could become very important in the future for chemistry, materials science, optimization, and secure communication. Even though these systems are still in development, they show that Russia is not only focused on visible hardware, like aircraft and reactors. It is also trying to compete in advanced computing and future technology. Number 6. Domestic AI servers and neural network hardware. Russia is also working on the hardware needed to support artificial intelligence. AI is not just about software. It also depends on powerful servers, cooling systems, and data center equipment that can handle heavy workloads. That is why Rostech's electronics company, Rosell, announced a new line of Russian-made servers for AI, big data, and high-performance computing. Rostech also said it started commercial production of neural network equipment with an advanced liquid cooling system, built to manage the heat created by demanding AI tasks. These systems were presented as practical tools to reduce dependence on imported hardware. Why does this matter? Because the AI race is not won by software alone. A country also needs the physical machines that run and support that software. By building its own servers and neural network equipment, Russia is trying to strengthen the foundation behind its AI ambitions. Number 7. Large-scale drone components production. Russia is not only trying to build more drones, it is also trying to mass-produce the important parts inside them. These hidden components, like navigation modules, sensors, antenna systems, and software, decide how well a drone can fly, stay on course, and operate during difficult missions. Rostech said it had launched large-scale production of key drone components, including navigation modules with protected domestic software, integrated satellite antennas, and mini barometers. According to the company, these parts help drones know their position, follow their mission, and send condition data while flying. In simple words, Russia wants to localize the electronics that make drones actually useful. Why does this matter? Because drone power is not only about the body of the aircraft, it is also about the internal electronics that guide it. If a country can mass produce those parts, it can build and deploy drones on a much larger scale. Number 8. Satellite-free navigation for UAVs. Russia is also working on navigation systems that can guide drones even when satellite signals are weak, jammed, or completely blocked. This is important in modern warfare, where electronic warfare can easily disrupt normal navigation. Rostech said it had developed a satellite-free navigation system for aircraft, helicopters, and unmanned aerial vehicles. The company said the system was designed to work in conditions where satellite communication is unstable or deliberately suppressed. It was also described as resistant to electronic warfare, already flight tested and ready for serial production. Why does this matter? Because a drone that loses its direction can become useless very quickly. In real combat, reliable navigation can decide whether a mission succeeds or fails. So this technology is about helping drones and other aircraft keep moving, even when the electronic environment becomes hostile. Number 9. New laser drone defenses. Russia is also testing laser systems designed to stop drones. Instead of using another missile, the idea is to use a powerful beam to damage or destroy an incoming drone almost instantly. It sounds futuristic, but Russia said it carried out large-scale tests of these systems in 2025. Reuters reported that Russia announced tests of promising laser weapons for drone defense. The information came from official Russian statements, which said the tests were part of a broader effort to improve air defense against the growing drone threat. However, these were official claims, not fully independent public demonstrations, verified in complete detail. Why does this matter? Because drones are often cheap and can be used in large numbers, while the missiles used to stop them are usually much more expensive. If laser defenses become practical, they could offer a cheaper and faster way to counter mass drone attacks. Number 10. Oreshnik missile and Poseidon underwater drone. The final part of Russia's technology push moves into strategic weapons. These systems are not about passenger travel, electricity, or AI hardware. They are about deterrence, pressure, and sending a message to rival powers. One of these is the Oreshnik missile, which Reuters described as a new Russian intermediate-range ballistic missile used against Ukraine. Reuters said Russia presented it as a major new weapon, although some Western experts questioned how strong all of Moscow's claims really were. Another system is Poseidon, the nuclear-powered, nuclear-capable underwater drone that President Vladimir Putin said had been tested successfully. AP reported that Poseidon was presented as one of Russia's next-generation strategic weapons. Why does this matter? Because these systems show the widest and most dangerous side of Russia's technology strategy. Russia is not only trying to improve industry, energy, and computing, it is also trying to project military power through weapons designed to shape fear, deterrence, and global attention. Russia's technology story is no longer only about traditional military strength. It now includes aircraft, small reactors, quantum research, AI hardware, drone systems, laser defenses, and strategic weapons. Together, these developments show a country trying to reshape its future under pressure. If you enjoyed this video, like, share, and subscribe.